Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session of circular motion, we just introduced the basic terminology related to the circular motion. So what is angular displacement, angular velocity, angular acceleration? So these are the basic terms, and we have seen some previous year questions related to that, right? So in continuation of the circular motion, we are going to start the lecture number 2 today. So in lecture number 2, so we'll study the centripetal and tangential acceleration and the dynamics of the circular motion. So from here onwards, the dynamics of circular motion will begin. But before that, mostly today's topic, 70 to 80% of the topic will be centripetal and tangential acceleration. We'll understand it in detail. So then we'll go for the introduction of dynamics of circular motion in the next class, that is tomorrow, Sunday. Also I am uploading the class tomorrow. Okay, so where we are going to discuss the dynamics of circular motion in detail. Okay, chalo. So as usual, for the next 1 hour, just be with me, guys. Avoid all the disturbances around you, and it's very important to write your own short notes at the end of the lecture. Okay, so with very high positive energy, let's start the today's session. So first, let's understand what is the centripetal acceleration and what is the tangential acceleration. So this centripetal acceleration is also called as the radial acceleration because it always acts along the radius. Radial acceleration, so which acts along the radius. Okay, so what is centripetal acceleration, sir? See, so when a body is moving in a circular motion like this, let's suppose a body has started from here. Okay, so if the body's velocity is constant throughout its motion, I can say speed, let's say speed. So if the body is maintaining the same speed throughout the circular motion, so then what is that circular motion is called? You know that in the grade 9th level. So uniform circular motion, yes or no? So that's what I wrote. When a particle is in uniform circular motion, its speed remains constant throughout its motion in the circular path. So if its speed remains constant, so here the speed is, let's suppose, magnitude of v, here the magnitude of v, here the magnitude of v. So if the speed is constant throughout its motion along the circular path, then the body is said to be in uniform circular motion. So which we write it as UCM, uniform circular motion, right? So first point. And then the velocity of the particle changes due to change in direction. Sir, its speed remains constant. See, understand carefully. Its speed is remaining constant. So while the particle is moving, so does it have any velocity, sir? Is there any velocity change? The velocity changes. The velocity still changes, but not due to the speed. It's due to the change in direction. It's due to the change in direction. Due to the change in direction. So see, the simple understanding is whenever a body is moving in the circular path, so it's maintaining the constant speed. So its velocity is constant or not? No, velocity will have magnitude as well as direction. So among these two, if any one changes, then the velocity changes, obviously. So here the speed is remaining constant, but the direction changes. See here, the particle's direction at this point is this side, and at this point the direction of the particle is this side, at this point this side, and at this point this side, and at this point this side. So like that, the particle is maintaining different directions at different points. So that means its velocity is changing due to the change in direction. So then shall I say the acceleration, if whenever the velocity changes, so then acceleration comes into the role, right? So what is that acceleration is called? The acceleration due to the change in the direction of velocity is called the centripetal acceleration. So the acceleration which is due to the change in the direction of velocity, not due to the speed, due to the change in speed of velocity, no. Due to the change in direction of velocity, that's called the centripetal acceleration. Okay, the centripetal acceleration is directed towards the center of the circle. See here, so it is always directed towards the center of the circle. Here AC, and here AC, and here AC. The centripetal acceleration is denoted with AC, is denoted with AC, and is given as, so let me write the formula. So here again let me draw the diagram once. So this is a circular path, so center, so AC, 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 not the AC in our rooms, it's a centripetal acceleration AC. Okay, so here the velocity will be this side, and here the velocity will be this side, and here the velocity will be this side, and here the velocity will be right side. So now see here, the centripetal acceleration AC is a centripetal acceleration or radial acceleration. It's a centripetal acceleration, or which is also called the radial acceleration. The radial acceleration. So which acts along the radius. Okay, fine, this part. Chal, next. So this AC formula is given as V square by R. So where R is the radius of the circular path. So where R is the radius of the circular path. Radius of the circular path. Right. So now we know that V is equals to R omega. Here just I am writing the different forms of this. So we know that V is equals to R omega. So now in place of V I am substituting R omega. So R omega whole square by R. So which is nothing but R square omega square by R. So which is nothing but AC is equals to R omega square. AC is equals to R omega square is the centripetal acceleration. So and this is also one formula in terms of V and R, in terms of R and omega. Let's write in terms of V and omega. Let's write in terms of V and omega. So then what I am doing is in place of R, shall I write V by omega? V by omega. In this I am substituting in place of R V by omega. So which is nothing but V by omega into omega square. 1 omega cancel. So which is nothing but the V omega. Okay. So chalo. So here the complete acceleration, that centripetal acceleration, which is equals to V square by R, which is equals to R omega square, right, which is equals to V omega. So depending on the given information, you can use any of these formula. Okay. So depending on the given information, you can go for the any of one of these formulas while solving the numericals. Chalo, clear guys? So write along with me again the formulas. The centripetal acceleration is equals to, so V square by R, or R omega square, or V omega, all are same. Right along with me. Done? Clear till here? Read out here. So the only thing that you have to understand is in the centripetal acceleration will always act towards the center, okay. So it's due to the change in direction of velocity. Right? That's what we wrote. It is due to the change in the direction of velocity. And then, so remember in the uniform circular motion, so and one more point, write down here. So I'll write here. In uniform circular motion, so the AC is not equals to 0. The acceleration is not equals to 0. So uniform circular motion means only its speed is constant, but its direction changes. Due to the change in the direction, the acceleration that acts towards the center is the centripetal acceleration. Okay, clear? So why I am repeating this one is the questions can be framed in different ways. Okay, so that's why you should understand each and every point in detail. Right? Chalo. So let's take one simple question, guys. So I'll stand aside. So just try this question. I'll give, just get the idea. 10 seconds time I'll give. So just have the idea. Simple question. A particle moves in a circle of radius 5 centimeters. See here, this is a radius circle whose radius is 5 centimeters. Fine. So with constant speed, so the speed is not changing, constant speed. So and time period 0.2 pi seconds. So the acceleration of the particle. So if its speed is constant, which acceleration will be there? That acceleration should be the centripetal acceleration. If the speed is constant, the acceleration will be only due to the change in the direction of velocity. So due to the change in the direction of velocity, which acceleration? The centripetal acceleration. So now the thing is, so AC is equals to, so shall I write which formula shall we use? Which formula shall we use? So better let's use R omega. R omega, because we know the radius and we know the time period is given. So what's the time period? The time period is equals to 0.2 pi seconds. Right. So can we find omega from here? The omega is equals to 2 pi by t. Right. So 2 pi by, in place of t you can write 0.2 pi. So pi cancel. This is 2 by 10. You can write 2 cancel. 10 will come. So that means omega we got it as 10 radian per second. Omega, let's write it as 10 radian per second. So 10 radian per second. So now AC is equals to R, radius converted to meters, 5 by 100 into omega 10. So 0 cancel. AC is equals to 5 by 10, which is 1 by 2. So sorry. AC is equals to R omega, acceleration only, right? They said omega is what? Omega is equals to 2 pi by t. Sorry, R omega square, my bad, right? Yeah. Sorry. AC is equals to R. What is R? 5 by 100 into omega is 10 into 10. So here 0 cancel and 10 cancel. So then AC is equals to 5 meter per second square. Option D is the correct one. Clear guys? Understood? Chalo. So let's move further. So let's take the next type of acceleration. So if the speed of the particle is also changing in the circular motion, that is velocity also changes in magnitude as well as direction. So then we have the acceleration that acts is a tangential acceleration. Okay. So see here, if the particle is maintaining so different speeds at different points in its circular motion, in its circular path. So here some velocity, here some velocity, here some velocity, here some velocity, so that its velocity is changing. So the tangential acceleration will act along the tangent. So if the particle is here, the tangential acceleration will be this side. If the particle moves to this point, so the tangential acceleration will be AT, this side. So the tangential acceleration is due to the change in magnitude of velocity. Due to the change in magnitude of velocity. So again I am writing here the tangential acceleration, it is due to change in magnitude and direction. Direction also changing, right? Due to change in magnitude and direction of velocity. Yes, this point is clear guys. So now, so what's the formula for that? You can write, so the AT is equals to simply the dV by dt. So the magnitude of velocity by dt. So this is a tangential acceleration. So clear? Is the tangential acceleration part clear everyone? Just the formula. So now here, now let me ask this question. So in the uniform circular motion, so tell me the AC is 0 or not in the uniform circular motion. So shall I say that the AC is not equals to 0? Uniform circular motion means the speed is constant. So if the speed is constant, AC is not equals to 0, right? But AT is equals to 0. Shall I say the tangential acceleration will not be present? Agreed? Agreed guys? So AC will not be equals to 0, but AT will be equals to 0 in the uniform circular motion, because the tangential acceleration is due to both direction change and speed change. In the uniform circular motion, there is no speed change, only the direction change occurs, right? So that's why AC will exist, AT will be 0. Remember this point as well. Clear? Both the types of accelerations are clear everyone? Sure. So let's move further. What is the relation between the tangential acceleration at and the angular acceleration alpha? See, in the previous class, we have studied the relation between linear displacement, angular displacement, linear velocity, angular velocity. So what is that? S is equals to r theta, V is equals to r omega, and then so here this is a linear velocity and this is a linear displacement, angular displacement, linear velocity, angular velocity. So now the acceleration will also be equals to r into alpha. But what is this acceleration? Whether it is the tangential acceleration or the centripetal acceleration, that's the question, right? See, by comparison you can say that S is equals to r theta, V is equals to r omega, A is also equals to r alpha. Fine. But what is this acceleration? We have two types of accelerations, right? Centripetal or tangential. Which one? So then let's see. See, I am taking the centripetal, the tangential acceleration, which is equals to the dv by dt. So the tangential acceleration is equals to d. So which we can write here r omega. In place of v, we can write r omega by dt. So the at is equals to, r is the constant, take it out. So the d omega by dt. So what is d omega? Due to the change in velocity, change in angular velocity. So what is the acceleration that comes? That's an angular acceleration. Yes or no? Due to the change in angular velocity. So the acceleration that comes is the angular acceleration, right? Yes or no? D omega by dt is nothing but angular acceleration, instantaneous angular acceleration, right? So we have seen it in the last class. So therefore at is equals to r alpha. The tangential acceleration is equals to r alpha. The tangential acceleration is equals to r alpha. So that means in this relation, so this this a will be the tangential acceleration, not the centripetal acceleration, because in the centripetal acceleration the speed will not change. See here, alpha is equals to, if it is in the alpha is equals to d omega by dt, right? So in the UCM, so the d omega will not change. So if the omega is not changing, the angular acceleration will be equals to 0. Yes or no? The angular acceleration will be 0 in uniform circular motion, because its angular speed will not change with the time. So this term is going to be constant, omega. So if it is constant, the overall angular acceleration will be 0. Just understand the basics. We are not doing anything more. So the centripetal acceleration is due to the change in direction of the velocity, and tangential acceleration is due to the change in velocity of magnitude as well as direction, both. Okay, and then so the relation between what is the tangential acceleration and angular acceleration, it is at is equals to r alpha. So between the centripetal and angular acceleration there is no relation, because in the UCM the centripetal acceleration will occur only in the uniform circular motion. So in the uniform circular motion alpha will be 0, the angular acceleration. Hope this concept is clear, guys, right? Chalo, so let's move further. Now, so we have two types of accelerations for the body, right? A particle, if it is moving in a circular path, so we have seen it has two accelerations. What are those accelerations? Let's consider a particle is here. So along the tangent it will have the tangential acceleration, and along the radius it will have, see here, so this is at along the tangent, and this one AC along the centripetal acceleration, right? So now what is the net acceleration? The net acceleration will be this side. So this is the A net. This is the A net. So let me write it clearly here. So let's suppose the particle is here. So the tangential acceleration is this side, and then the centripetal acceleration is this side. So then the net acceleration of the particle will be between these two. Obviously these two are perpendicular to each other. These two are perpendicular to each other, guys. Yes or no? So now, so let's take this angle as theta. So I can say this is a net acceleration. So we can see that the net acceleration is equals to square root of AC. If you parallel shift this one, if you parallel shift this to this side, so then what it will be? AC square plus AT square. This is a net acceleration. And then so one more thing, the tan theta you can write. So the tan theta is equals to opposite by adjacent. If you shift this to this side, parallel shift, so AC by the AT, the AC by AT, tan theta is equals to AC by AT. Clear? So this is one thing. And one more thing, see the tangential acceleration, shall we write it as the A net into cos theta? A net into cos theta. This side cos component will come, right? So A net cos component, and opposite side the sin component come. The centripetal acceleration will be equals to A net sin theta. A net sin theta. This is also one of the important concept. Clear? So when the body is moving in a circular path, so it will have, if it is a non-uniform circular motion, we are talking about non-uniform circular motion. In non-uniform circular motion only the tangential acceleration will exist. Otherwise, if it is a uniform circular motion, only acceleration that exists is a centripetal acceleration. So in non-uniform circular motion, both the accelerations will exist. So one is the tangential, the other one is a centripetal. So now what is the net acceleration of these two? So which is A net is equals to square root of AC square plus AT square, and tan theta is equals to AC by AT. And tangential acceleration you can write A net cos theta, centripetal acceleration you can write A net sin theta. Done guys? Clear this part? Chalo. So next, so let's take the question. Try this question on your own. Try this question. What's the given information? Try this question on your own. So I'll just stand aside. First try it on your own. Figure. A car is traveling along a circular path. This one, traveling along a circular curve that has a radius 64 meters. Fine. And then, so if its speed is 16 meter per second and it's increasing at uniformly 3 meter per second square. So determine the magnitude of the acceleration of the car. See here. So what they are saying, magnitude of acceleration of the car. Okay, fine. So if its speed is 16 meter per second, initial speed, and it's increasing at the uniform rate 3 meter per second square. So what is this acceleration that is given? Its speed is increasing. If the speed is changing, what acceleration it is? The tangential acceleration I can say. So the tangential acceleration is given as 3 meter per second square. The acceleration due to the increase in speed is going to be obviously the tangential acceleration, right? Chalo. So now can we find what is AC is given? So, AT is given. Can we find what is AT? So it's V square by R, right? So the velocity V is also given, I guess. So velocity V is 16 meter per second. Yes. So simply substitute the value now. This is 16 into 16 by, so R is 64. 16 ones are 16 fours are 4 ones are 4 fours are, right? So this is 4 meter per second square is a tangential centripetal acceleration. So draw the circular path. So here you can say that the body, if the particle is moving in this circular path, so it has the centripetal acceleration towards the center, and it has the tangential acceleration along the tangent, right? So this is 3 and then this is 4 we got, right? So obviously the A net, what is the magnitude of the acceleration of the car? Here acceleration of the car means the net acceleration they are asking, because the body is moving in the non-uniform circular motion. In the non-uniform circular motion, because its speed is changing. Clear? So A net is equals to square root of AC square plus AT square. So here what is AC whole square? 3 square plus 4 square. So which is 25, which is nothing but 5. So the net acceleration is equals to 5 meter per magnitude they are just asking. So which is 5 meter per second square. So if they asked you to find what is theta also, you can find the theta. So this is going to be 5. So if this angle is theta, so then you can say the tan theta is equals to opposite 4 by adjacent 3. So opposite to theta 4 means this is going to be 53 degrees, right? Yeah, so theta is equals to 53 degrees. You can find this angle as 53. So if they ask what is this angle, so it's going to be 37 degrees. This is 37, this is 53. Clear? Understood, guys? Chalo. So let's move further. Chalo. So let's take the next question. So try this question on your own. Try the question on your own. I'll just stand aside. Just understand the given information. See, the speed of a particle moving in a circle of radius r is equals to 2 meters. Fine. First understand the given information. Varies with time. So its speed is changing with respect to time, t square. So where t is in second and v is in meter per second, find the radial, tangential and net acceleration. So let's do one by one. So radial means the tangential radial or centripetal. Both accelerations are same. Radial or centripetal acceleration. Let's find radial or centripetal acceleration, where they are asking at t is equals to 2 seconds. So shall I say that here the radial acceleration formula is equals to, so here v is given and then r also we know. Let me use the formula v square by r. Let's use the formula v square by r. So but the thing is here v is given as a function of time. So v is equals to 2 t square. So but we need this acceleration at t is equals to 2 seconds. So therefore at t is equals to 2, the v will become 4. So that's why, so in place of v, which is 4 into 4 by the radius is 2 meters. So 2 ones are 2 twos are. So this is 8 meter per second square is a centripetal acceleration or radial acceleration. The first one done. Next, the second one we need the tangential acceleration. So let's go for the tangential acceleration. So the tangential acceleration at, the tangential acceleration which is at, so which is nothing but dv by dt, the magnitude of velocity changes, right? So which is nothing but d by dt of what is the velocity function is given, t square. So that means this is going to be 2t. This is going to be 2t. So now the at is equals to 2t. So now we at what? At t is equals to 2 seconds we need this, right? So t is equals to 2. So that's why it's going to be 4 meter per second square. So this is 8 meter per second square. This is 4 meter per second square. Now what do we need? The net acceleration. So let's write it in the new slide. So consider, let's draw the diagram of that. This is a particle circular path, and this side is a tangential acceleration and this side is a centripetal acceleration. So we have got the centripetal acceleration as 8 meter per second square. So this is 8 and this is 4. So now in the third question they are asking what is the net acceleration. So the net acceleration will be this side. So the a net will be equals to square root of ac square plus at square, right? Simple concept. Now shall I write, so what is ac? ac is 8 whole square plus at 4 whole square. So then this is 64 plus 16, so which is nothing but square root of 80. So let's write it as 16 into 5. So take 16 out, 4 root 5 meter per second square is a net acceleration, a net. So if they ask you to find what is the, so what is the angle, if you want to find this angle theta, so then the tan theta is equals to, we can also write ac by at, right? So from here the tan theta is equals to, what is ac, we got ac is 8 by the tangential acceleration 4. So therefore the tan theta is equals to 2. So the tan theta is equals to 2 is the correct one. Clear? Understood guys this part? Chalo. So let's move further. This one done. So the question number 3. So let's go for the next question. So try this question. Try this question guys. So first understand the given information, what it is given. What it is given first. So question read everyone. Chal. So the angular velocity of the particle moving in a circle of radius 1 meter. So here circular path. So here this radius is given as 1 meter. Fine. So varies with time. So here the angular velocity is varying with time. Omega is equals to 2t. So find the radial, tangential, net and angular acceleration. See here. So radial means AC you have to find. Tangential means AT you have to find. Net means A net you have to find. What is angular acceleration? Alpha you have to find. So at t is equals to 2 seconds we have to find this. So now let's solve one by one. So the first one, that radial or centripetal acceleration. Radial or centripetal acceleration. So how do we find that? So first thing is we know the radius and we know the omega. So the centripetal acceleration in terms of r and omega, which is r omega square. Yes or no? So and then we have got omega is equals to 2t, but we need it at t is equals to 2 seconds. So therefore omega at t is equals to 2 seconds will be equals to 2 into 2. So which is 4 radian per second, right? So the same thing I am substituting it here. So let's write the AC is equals to what is r? 1 meter into omega. What is omega? 2t. So in place of 2t, so you can write at t is equals to 2 seconds, the omega has become 4. So therefore the AC is equals to 4 radian per second square. Sorry, 4 meter per second square. This is the, what is this one? The tangential centripetal or radial acceleration, the first one. So then come to the second part. We need the tangential acceleration. What is tangential acceleration formula? What is the tangential acceleration formula? AT is equals to d omega by dt. Yes or no? Let's write d into v by dt. Yes, is this part clear? So shall we write dv by dt there? The simple thing, we are just substituting it in the formula guys, that's it. Yes or no? So from here, shall I write the AT is equals to in place of this d by, so what is this v? What is this change in velocity? So simply in place of v we don't know, so or else let's do this way. So the v is equals to r omega, we don't know v, right? So v is equals to r omega, can we find? So what is r here? R is 1 meter and omega is 2t. So therefore v also will become 2t. V also will become 2t. Yes. So in place of v you substitute 2t here by dt. So therefore 2 is constant, the differentiation of t is 1. So that's why 2. So this is AT is equals to 2 meter per second square. So now we have got AT and we have got AC. So can we find the net acceleration now? Here this side, like understand here. So this side the AT which is equals to 2 meter per second square, and this side the AC which is equals to 4 meter per second square. So now the net acceleration will be this side. This side the A net will be there, right? So what is that A net? The third question, which is A net is equals to AC whole square plus AT whole square under root. So which is square root of 2 square 4 plus this one 4 square 16. So which is nothing but root 20. So which is 5 root 2 meter per second square. So 5 root 2 meter per second square. So that's a net acceleration. Okay. Clear guys? Clear? Done? Chal. Sorry, I guess this should not be this one, right? I guess I did wrong here. Check it guys. Oh, sorry, this part, my bad. Here omega square, right? I just substituted 1 omega. Very sorry. So that's what I'm checking. So here 1 into 4 square. This is going to be AC 16, right? So AC is equals to 16 meter per second square. We got AC is equals to 16 meter per second square. So here AC, just change the AC value guys. This should be 16 here. This should be 16 here. This is 16. Yeah, now do it. A net is equals to square root of AC square plus AT square. Here R omega square, right? R is 1. Omega is what? 4. 4 square is 16, right? So here square root of AC square 16 square, which is 256, plus AT 2 square 4. So which is nothing but root 260. This is root 260 meter per second square. That's a net acceleration. So now what else they asked? So they also asked the fourth question, that is angular acceleration. What is angular acceleration formula? Alpha is equals to d omega by dt, right? So d by dt of what is omega? In place of omega we can write 2t directly, right? So then t, so obviously you can write directly, it is going to be alpha is equals to 2 radian per second square. So the alpha is going to be 2 radian per second square. Clear? Understood? Everyone? Basic information, that's it. So just look at that. Just look at that part. Just see the complete solution once. Done? So let's move further. Let's go for the next question, guys. Sorry. So see the question. A particle moves in a circle of radius 0.5 meters at a speed that uniformly increases. See here, speed that uniformly increases. Find the angular acceleration of the particle if its speed changes from 2 meter per second to 4 meter per second. See here, so its omega 1 is given 2 meter per second, and then its omega 2, see here, so its speed changes from 2 meter to 4 meter per second in 4 seconds. What we have to find, see here, so the angular acceleration of the particle. So first, what is the angular acceleration formula? So it's going to be d omega by dt. Yes or no? So d omega by dt. So now here the thing is, first what is d omega by dt? How can you substitute the d omega by dt there? How can you substitute d omega by dt? Understand carefully, or else see, if its speed changing means, let's come by this way. If its tangential acceleration shall we find first? The tangential acceleration is dv by dt. Its tangential acceleration is dv by dt. So how the speed is changing? The tangential acceleration is equals to, so it's going to be, the speed is 4 minus 2 by that, in the time 4. So that means the tangential acceleration is equals to, so which is 2 by 4, which is 1 by 2, which is nothing but 0.5 meter per second square is a tangential acceleration that we get. So once we get the tangential acceleration, so now we can find the, because we don't know what is omega, here it is meter per second, means velocity is given, the change in velocity. So obviously you can't go for d omega by dt directly, because this should be as given as a function. If it is given as a function, so then you can go for that, but here it's not given, right? Here velocity is given, velocity is changing from 2 meter per second to 4 meter per second in 4 seconds, right? So therefore the tangential acceleration, I'm using the formula. Now I got the tangential acceleration. So and we know that the tangential acceleration at is equals to r alpha. The tangential acceleration at is equals to r alpha. So in place of at we have 0.5 meter per second, right? So meter per second square, and this is 0.5, so into alpha. So therefore alpha is equals to 1 radian per second square. So the alpha value is equals to 1 radian per second square. Clear? Understood guys, everyone? Simple, just understand the procedure and proceed further. Next. So look at this question. So once have the question, just look at the question which was asked in NEET 2016. So in the figure, A is equals to 15 meter per second square represents the total acceleration. So here it is, net acceleration of the particle moving in a clockwise direction of circle of radius 2.5 meters at a instant of time. So the speed of the particle is, so here it is, this angle is also given. So this is a angle. So we know that obviously when the particle is moving in a circular path like this, here is a particle. So this side the centripetal acceleration will be there towards the center, and this side the tangential acceleration will be there this side. Yes or no? So and this angle is given as 30 degrees. This angle is given as 30 degrees. So and A net is given in the question. The A net is given. A net is equals to 15 meter per second square. 15 meter per second square. So obviously, can we find what is AC and what is AT there? The centripetal acceleration will be equals to A net cos 30. Yes or no? The centripetal acceleration AC will be equals to A net, its cos component will come, cos 30. So A net, what is the A net? 15 into, so cos 30. So the cos 30 value root 3 by 2. So this is going to be, let it be, and then AT, find the AT value. So which is A net sin 30. A net sin 30 degrees. So what is A net? 15 sin 30 1 by 2. So this is 15 meter per second square. So we have got AC and we have got AT. So then we need the speed of the particle. Speed of the particle means we need V. So now think. So how do you find the V? We need the V. So just which formula we can use so that you can find the V? Just have the basic understanding. We know the centripetal acceleration. Shall I write AC is equals to directly V square by R? Right. So from here, what is AC? 15 root 3 by 2. We know this. And R, V square. What is V? We have to find by radius. They gave it in the question, I guess. What is the radius? 2.5. They gave it in the question. Yes or no? So then, so I can write. So here, just do the calculations here. So V square is equals to, so 15 into 2.5 into root 3 by 2. Alright. So 15 into 2.5 into 2. So calculate this value, approximately how much you are getting. So this is going to be 30 and 7.5. So this is 30 and 7.5. 37.5 into, this is 1.732. So check the options are bit close. So just follow carefully, by 2. Okay. So then this is going to be 2 ones are, 2 ones are, 2 8s are, and then 1 5. So 1 5 means 2 7s are, and then 2 5s are. So which is nothing but 18.575 into 1.732 into 1.732. So this is the V square value. So then find the V value. So the V is equals to square root of 18.75 into 1.732. So how much we get? So this is approximately, can take it as 2. So 36, nearly 5 or 5.7. So nearly 6 means we can take approximately 5.7. You just calculate that. So we'll get approximately 5.7 meter per second. Clear? Just do the calculations. Okay. Chal. So let's move further. This question was asked in NEET 2016. Simple question. So let's take the next question, guys. So what's the question says? See here. A particle starts from rest, moves in a circular path of radius 4 by pi meters. Radius is given. So if its angular acceleration alpha is given, 2 pi radian per second square. Angular acceleration is given. Find the velocity of the particle after the second round. So after the second round means, try to understand here. After the second round, let's suppose, so the particle, let's suppose, started from here. So then let the radius of this circle be R. Okay, so for the first round, what is the total distance covered? The circumference 2 pi r. And after the second round means when it comes here, again, what is its speed? When it comes here, what is its speed they are asking? Find the velocity of the particle after second round. So to cover the second round, the total distance covered by it is 2 into 2 pi r, I can say. 2 into 2 pi r. So which is nothing but 4 pi r. So 4 pi r. Yes or no? This is the total distance. Now, so the particle has started from rest. U is equals to 0. And then alpha we know, which is 2 pi radian per second square. So shall we use the formula? So v square minus u square is equals to 2as. V square minus u square is equals to, we can use the formula 2as. So what is that a? The tangential acceleration. The tangential acceleration can we find, which is r alpha. What is r? R is given as 4 by pi and alpha is given as 2 pi. So pi cancel. This is going to be 8 meter per second square. So we have got alpha as 8, and then this here also you can substitute the values. 4 into pi into what is the radius? Yes or no? So 4 into pi into radius is 4 by pi. So which is nothing but total 16 meters. So you know S, you know A, and you know what we need to find actually? The velocity V we have to find. So the only unknown is velocity V. You can easily find. So let's calculate that, guys. Quicker. So everyone, let's calculate that quickly. Simple question. So no need to struggle much, right? So direct formula based question. So V square we have to find. So initial velocity 0 square, 2 into the acceleration. What is the acceleration? The tangential acceleration. 8 into, so this is 16, right? What is this S? S is 16, right? So then V square is equals to, we have got 2 into 8, 16 into 16. So V is equals to 16 meter per second. Option 3 is the correct one. Done. Clear? Chal. So let's move further. The question number 8. So what's the question says here? A particle moves along the radius that is given 20 by pi meters. Fine. So with pi constant tangential acceleration, with constant, don't take pi here. So this is constant tangential acceleration. If the velocity of the particle is 80 meter per second at the end of the second revolution. So at the end of the second revolution means how much distance total covered? Same previous type question. So 2 into 2 pi r distance is covered, right? So total 4 pi r distance is covered, where 4 into pi into radius is given as 20 by pi. So cancel pi. So that we got the distance covered at the end of the second revolution is 80 meters and radius we got. So after the motion has begin means its initial velocity 0, right? So the tangential acceleration is what they are asking, the tangential acceleration. So what is the velocity? V is also given. V is equals to 80 meter per second. Same previous type question. Just use the V square minus U square is equals to 2as, right? So we have got V. V is 80 whole square. Initial velocity 0. So this acceleration is a tangential acceleration. A into what is S? S is 80 we got. So here 180 cancel. So that 80 is equals to 2 into A. So A is equals to 80 by 2, 40 meter per second square is a tangential acceleration. So which is 40 pi meters per second square. No, 40 meter per second square. Option B is the correct one. Clear, guys? Understood? Chal. So the next one. A particle is starting from rest. So its initial velocity is 0. Moves in a circle of radius r. So the radius r is equals to r. It attains a velocity of v is equals to v naught. So its velocity v is equals to v naught at the end of the nth round. So what is the distance covered? So 2 pi r into n. 2 pi r into n is the distance covered. So then what is its angular acceleration? So what is its angular acceleration? So first let's find what is its tangential acceleration. V square minus u square is equals to 2as, same concept, right? So the tangential acceleration I am finding here. What is v? V is equals to v naught square, initial velocity 0, 2 into, here in place of a you write tangential acceleration at into, so the total distance covered is 2 pi rn. From here the tangential acceleration is equals to v naught square by 2 into 2, 4 pi rn is a tangential acceleration. But they are asking what is angular acceleration. See here in the question they are asking the angular acceleration, right? So we know that the tangential acceleration is equals to r into alpha, right? So from here the tangential acceleration we can substitute v naught square by 4 pi rn, which is equals to r into, so alpha, right? So in place of r we can simply write r itself. So here in the question it is given small r, let's write small r itself. So I can write here the alpha is equals to v naught square by, we need alpha only, right? So v naught square 4 pi rn alpha r, 4 pi r into r square you can write. So v naught square by 4 pi n r square should be there, v naught by n, v naught square by 4 pi, no 4 pi, v naught square by 4 pi n r square. Yes, option 4 is the correct one. Clear guys, understood? Chal. So now, so the next concept is a centripetal force. See, when a particle moves in a circular path, so a centripetal acceleration is present. So as we discussed earlier, here the particle is moving in the circular path, so the centripetal acceleration is present. So now this centripetal acceleration AC is directed along the radius towards the center of the circle. We already discussed that point also. So as there can be no acceleration without a force, so if the acceleration is acting towards the center, means there must be a force acting towards the center. There must be a force which is acting towards the center, right? So a centripetal force acts on the particle along the radius towards the center of the circle. As the acceleration is towards the center, so there must be a force that acts on the particle. That force we call it as the centripetal force. Okay, so that centripetal force we can give it as Fc is equals to mass of the particle into its centripetal acceleration, right? So we can write the Fc is equals to m into, in place of AC you can write v square by r, in place of AC you can write r omega square, in place of AC you can write v omega, anything you can write. So therefore the centripetal force which acts on the particle which is moving in a circular path along its radius, so that is the centripetal force. Okay, that is the centripetal force which is given by the formula Fc is equals to mv square by r, or mr omega square, or mv omega. Done? Understood guys? Chalo. So let's move further. So the work done by centripetal force and change in kinetic energy. So the work done by centripetal force and change in kinetic energy. See here. So here if the particle is moving in the circular path, so the centripetal force is acting towards the center. The Fc, it is towards center. Towards center. Just understand the basics here. And then, so the particle displacement will displace along the tangent. The particle, see here, well, if the particle is moving from here to here, the particle is moving along its tangent. So the displacement, the particle's displacement is along the tangent. The particle's displacement is along the tangent. So now at any point you can consider, at here, or if the particle has moved to this point. So this is the mass of the particle m and it has moved to this point, so that its velocity will be this side, and yes or no. So this displacement, let it be ds this side, and the centripetal force Fc this side. So therefore we know that the work done, the very small work done dw is equals to, so the mass of the particle, the force acting on it into the small displacement. So here force and ds, they are perpendicular to each other. The Fc and ds are perpendicular to each other, so that the work done will be equals to 0. So that means the total work done will be equals to 0. So the work done by a centripetal force is 0. Clear? So now, and we can write it like So what is the change in kinetic energy? So the work done is equals to the change in kinetic energy. The work done is equals to, as per the work energy theorem, you studied it in the grade 9th, right? So the work energy theorem, again we'll study it in work energy power chapter. So but you already know the basic, right? So what is that? From the work energy theorem, so the work done will be equals to the change in the kinetic energy. Yes or no? So the work done will be equals to change in kinetic energy means, so the kinetic energy final minus the kinetic energy initial. So the work done by the centripetal force is 0. So I can take it as 0. So KEF minus KEI is equals to 0 here. So that's why shall we take, so the KEI is equals to KEF, right? So if the mass of the particle is m, so we can say its initial velocity is Vi. So half mvi square is its initial kinetic energy, and same particle will have the mass m and its final velocity, let it be Vf. So Vf square, half m cancel. So the Vi square is equals to Vf square. So that means, so the initial velocity will be equals to the final velocity. So there will be no change in kinetic energy. The initial kinetic energy will be equals to final kinetic energy. So the initial velocity is equals to the final velocity. So this is the work done by the centripetal force and the change in kinetic energy. Clear, guys? Chalo. So let's move further. Let's take one simple question here. So what's the question says? A 500 kg car turns a round of radius 50 meters with a velocity 36 km per hour. The centripetal force. So very simple question. So mass is given 500 kg, radius of the circle is given 50 meters, and then velocity is given 36 km per hour converted to meter per second. So 18 ones are 18 twos are, so this is going to be 10 meter per second, right? So then the centripetal force Fc is equals to, I know, mvr. So let's use the formula mv square by r. So mass of the particle 500, v square, what is v? 10 into 10 by r. R is what? 50, right? So this is going to be 10 times. So then, so the total 1000 newtons is the centripetal force, right? So basic question. Next, so when a body moves with a constant speed along a circle, constant speed means uniform circular motion, right? Uniform circular motion, constant speed. No work is done on it, no acceleration is produced. Acceleration will be there, AC will be present. AC present, no acceleration, they are saying no. Acceleration will be present. Its velocity remains constant. Its velocity changes due to the direction. Velocity changes due to change in direction. Due to change in direction. So the second one is correct, third one is correct. So no force acts on it, no work is done on it. So when the particle is moving in the uniform circular motion, so shall I say its initial velocity is equals to its final velocity, there will be no work is done on it. The work done will be equals to 0. Just now we have seen, right? So no force acts on it. No force acts. The force is equals to the force acts on the particle, and each particle, what is the force that acts? Towards the center. Just now we have seen, right? Towards the center, the force acts. Which force that acts? The centripetal force will act. So here the centripetal force will act. So the only correct option is the first one. The centripetal force acts. Clear? Understood, guys? Everyone? So chalo. So the centripetal force is not a new kind of force. Some or other force acts as a centripetal force. See, so we are talking about the centripetal force which is acting towards the center of the particle while it's moving in a circular path. So actually this centripetal force is not a new force. See, for example, so here revolution of earth around the center, the revolution of earth around the sun. Here is the sun and here is the earth. So here between these two, so there exists a force of gravity. So here the centripetal acceleration is nothing but the gravitational force between those two, right? So where g m1 mass of the sun into mass of the earth by the distance square, that's it. So that means the centripetal force is not a new kind of force. Here the gravitational force is acting as a centripetal force, that's it. So or else you can take another example. A particle is tied to string and drilled in a horizontal circle. Let's suppose you drilled in a horizontal circle, a particle is tied to the string and you drilled it in this way. So then in that string, so the tension will act towards a fixed point, yes or no? The tension will act. So the tension, see here towards this, the tension will act. So the tension is nothing but the centripetal force here. So the centripetal force is not a new kind of force. Somewhere, somehow, the other forces will act as a centripetal force depending on the situation. So here, between the sun and earth, the gravitational force is acting as a centripetal force. So here when you reel a string, a stone which is attached to the string in a horizontal circle, then the tension in the string acts as a centripetal force. That's it. Okay, clear guys? So that's it from my end. So just we started the basics of the dynamics of circular motion. So in the next class, that is tomorrow, we'll understand the in detail explanation of the dynamics of circular motion. So if you have any doubt, just comment down. So we'll meet in the next session guys. So till then, keep studying. All the very best. Bye.